Okay, so I'm probably going to do like 3 or 4 problems just as review to kind of make sure we know what's going on. The big thing we've done in both sections is really find our derivatives. So you can expect to have to do those. So let's say I ask you to find f prime of x if f of x is 2 over 4 minus x. What is the definition of derivative? Yeah, it's the rate of change. It's our slope of the tangent line. You have to do the limit as h approaches 0. You should write that limit on every step until you plug it in. F of x plus h minus f of x all over 8. The only difference we did between section 7 and 8 is in section 7 they left that as an a because we were just plugging a number in every time. In general, at this point I'll probably just leave them at x's and plug in if I need to. So this would be the limit as h approaches 0. F of x plus h, if I plug an x plus h in up here, I have 2 over 4 minus x plus h minus f of x all over h. Okay, can you leave it like this? No. So we can't plug in the 0 yet because we're getting a 0 on the denominator. So what we did is multiply to get rid of it. So we had to multiply by both denominators. 4 minus x minus h and 4 minus x. And whatever you do on the top, you do on the bottom as well. When you do that, in the first fraction, that denominator cancels, so you have 2 times the 4 minus x. In the second fraction, the 4 minus x cancels, so you have 2 times 4 minus x minus h over our denominator. Now what? So we get 8 minus 2x minus 8 plus 2x plus 2h over h times the 4 minus x minus h and 4 minus x. And then I can see my 8's drop, my 2x drops. I have limit as h approaches 0 of 2h over h times 4 minus x minus h and 4 minus x. So now you can cancel that h, which was our whole goal. So if you plug in 0 for your remaining h, you have 2 over 4 minus x minus 0 and 4 minus x, or 2 over 4 minus x squared. And that's our derivative.
Would you want us to roll that out?
No. Okay. Question 6? Let's do another one. So I want the equation tangent to the curve y equals radical x minus 1 at the point 10, 3. So here's an equation. To write the equation of a line, you need a slope, a point and a slope, right? I gave you the point, we need the slope. How am I going to get the slope of the tangent line? So we have to do this derivative, don't we? And then we're going to have to plug in. So we're going to do the limit as h approaches 0. Now we have two options. We can do it just like we did on the last one. Since we're going to want it at a particular point, instead of using an x here, I could go ahead and use a 10, because that's my x value. It doesn't matter. How would you guys prefer?
Like this.
Like this.
Yeah.
Sounds good. Then you're just remembering one thing, right? So f of x plus h. You go to your problem, you plug in an x plus h minus f of x over h. What do we do on our radical problems? How did you get it? If you take a radical times itself, the radical drops. So I get x plus h minus 1 minus my x minus 1 over h times my radicals. Now what? If I run my nade through, then my x's drop. I've got h over h times this. So now you can drop your h and plug in. Get 1 over x plus 0 minus 1. Or 1 over 2 radical x minus 1. That's the derivative. Am I done? No, I want the actual equation of a line. The derivative is your formula for slope. I need to know my slope when x is equal to 10. So if I plug a 10 into here, I get 1. So 10 minus 1 is 9. Square root of 9 is 3. So I get a slope of 1/6. So now I can use my point, my slope, because I asked for the full equation. So if you plug into y equals mx plus b, y is 3, m is 1/6, x was 10. 10 over 6 reduces to 5 over 3. Subtract that over. 3 is like 9 over 3 minus 5 over 3. So we get y equals 1/6 x plus 4/3. Yes, sir.
Where'd you get the x equals 10? Was that in the
Yes,
pair?
I asked for the equation of the tangent line at the point 10, 3. Okay, so equation of a tangent line, you do the derivative to get your slope formula, and then plug in your point and slope. Is that one all right? Let's see if we can do 1 or 2 more quick ones before the end of class. Let's say the height of an object is given by the equation y equals 60t minus 16t squared. Find the velocity after 3 seconds. Okay. So, how do we find velocity? What? Yeah, we have to do the derivative first, because this is position, derivative of position is velocity. So we're doing the limit, h approaches 0, f of x plus h, minus f of x all over h. So you're really doing this on practically every problem here, guys. So the limit, h approaches 0, 60 times x plus h, 16 times x plus h squared, 60x minus 16x. So distribute, we get 60x plus 60h. We have to FOIL this one and distribute a negative 16. So x plus h squared, that turns into x squared plus 2xh plus h squared. Multiply a negative 16, so we get negative 16x squared minus 32xh minus 16h squared. Then I have my minus 60x and plus 16x squared over h. At this point, we look for things that can cancel. So the 16x squared drop, 60x's drop. Everything that's remaining has an h in it, so we could cancel an h out. So that gives us 60 minus 32x minus 16h. If I plug in a 0 for my h, I get 60 minus 32x. That's my derivative, so that's my equation for the velocity. So the velocity at 3 seconds, you're going to plug a 3 in. So we get 60 minus 96. We get a negative 36 feet per second if you want to include units.
So, what was that thing? Like, you have
It's
to-
going down. Velocity is like speed with direction. So a positive velocity means it's going up, negative velocity is going down. Questions there? One last problem. Everybody's favorite. Let's draw a derivative.
It's better than trying to make a slope.
I won't have you actually like calculating slopes. Now we did that one example in class where I gave you a graph and I gave you a series of things like g prime of 0, g prime of 2, g prime of negative 2, and asked you to put them in order. I might ask you to do something like that just to see if you have an idea of what the slope or what the derivative means in terms of the graph, but I won't actually have you doing one like problem number 1 on the homework. Okay, so we know anywhere we have a max or a min, the derivative is 0. Okay, this section of the graph was increasing, so that means my derivative is positive. This section of the graph was decreasing, so the derivative is negative. This section is increasing, so the derivative is positive. So, just a rough sketch along those lines.
Would you make us do more than one derivative, like drawing more than one derivative?
I could, if I asked you to draw the derivative of this one, you would just do the same thing. So this one is 0 right here, so its derivative would be right here. It's decreasing the whole time, so that would be negative, increasing the whole time, and so that would be positive. So I could ask you to do more than one. It's just kind of repeating the process. Yes, ma'am. Anything else? homework due tomorrow. We'll grade it, answer any homework questions, and then do the quiz. I'm not doing any additional quiz review tomorrow. So if you have a specific question, I'll answer it, but I'm not doing any other review.